1,000 animals, fitted with trackers, sent across the most dangerous migration routes on the planet. Only 3 made it back, every single time. 3.
Scientists have been quietly running one of the most ambitious wildlife tracking studies in history. GPS tags, satellite uplinks, biometric sensors. And what they found completely changed how we think about animal survival.
We're going to cover what migration actually does to an animal's body, the routes that kill the most, and exactly what those 3 survivors did differently. You'll want to stay for that part.
First, let's talk about what migration actually costs. These aren't Sunday strolls. The average migrating animal burns up to 60% of its body fat before reaching its destination. Some lose muscle mass, some go blind from exhaustion, some just stop.
The routes studied spanned 5 of the most brutal corridors on Earth: the Serengeti Crossing, the Arctic Tern Path, the Monarch Butterfly Corridor, the Atlantic Salmon Run, and the Wildebeest Loop through the Mara River.
Each route has what researchers call a bottleneck, a single point where predators concentrate, where weather turns lethal, where the animal has no escape route. Cross it wrong, and it's over.
Across all 5 routes, the mortality data looked like this. Up to 72% of tracked animals died or disappeared before completing even 1 full round trip. Only a fraction completed 2. And only 3 species averaged a near-perfect return rate across multiple full cycles.
So who were the 3? The Arctic tern, the bar-tailed godwit, and the leatherback sea turtle. Very different animals, very different routes, but they shared something almost identical under the hood.
Difference number 1. Timing precision. These animals didn't just migrate. They migrated on an almost surgical schedule. The godwit, for example, times its departure to catch specific wind corridors that cut its energy cost by up to 40%. Miss the window by even a few days, and the wind works against you.
Difference number 2. Preloading. Before departure, these animals bulk up in very specific ways. The godwit shrinks its own digestive organs to save weight and doubles its fat stores. It essentially rebuilds its body into a flying fuel tank. No other tracked species did this as efficiently.
Difference number 3, route memory. The surviving species showed remarkably consistent GPS paths year after year, within a few kilometers of the exact same corridor. Other animals drifted. Some drifted straight into predator zones or shipping lanes. Consistency kept them alive.
The Arctic tern is the most extreme example. It travels 44,000 miles round trip every single year. From the Arctic to the Antarctic and back, researchers tagged 1 individual and tracked it for 3 consecutive years. It returned within 2 kilometers of the same nesting spot all 3 times.
The leatherback turtle adds another layer. It navigates using the Earth's magnetic field like a biological compass. It can detect variations as small as 50 nanoseconds in magnetic intensity to stay on course across open ocean. With no landmarks, no GPS, just physics, hardwired into its brain.
So what does this tell us? Survival in migration isn't random luck. It's precision, timing, preparation, and route discipline. The animals that died mostly deviated. They rushed. They delayed. They tried shortcuts. And shortcuts in the wild usually have teeth.
Want the full species breakdown and the exact survival rates per route? Comment the word survive below. And if this kind of deep dive wildlife science is your thing, you already know what to do. See you in the next one.